Background of laptop prices prediction. The data emulate laptop price capturing various features commonly associated with laptop and their corresponding simulated prices. The dataset encompassing key attributes such as brand, processor speed, screen size, RAM size, storage capacity, and weight. The problem that may occur in laptop prices is fluctuation of the laptop price on the market. There might be a discount or even a fluctuation due to popular brands such as Asus and Acer. The need to study laptop price prediction is to know what may affect the laptop price on the market. Objective of laptop price prediction is to examine the correlation between laptop price with processor speed as variable. Second, to develop whether the laptop price increase with the variable which is processor speed. Thirdly, to prove that the dependent variable is processor speed. Importance of laptop price prediction. Firstly, the advantages that can contribute to the community for this case study is that consumers can predict the future price trend, which help consumers make better buying decisions. Other than that, consumers will have a better plan for their budgets by anticipating when laptop price may fluctuate. This is especially useful for organizations that need to purchase multiple laptops within a set budget, such as UITM with their parenthesis. Secondly, the advantages to the environment is that they will reduce e-waste. If people know what kind of laptop they want to buy, they will not buy another laptop that doesn't meet their requirement. It will increase e-waste management because it will promote the purchase of durable, repairable, and upgradable laptop that can help reduce e-waste, which is a growing environmental concern. The limitation in the study of laptop price prediction for factors that were excluded was durability. For example, military-grade durability, water resistant, or rugged design typically come with higher prices. Other than that, types of material such as aluminium, carbon fiber, or magnesium alloy will increase production costs, leading to higher prices of laptops.
Next is methodology. In 2.1 is data description. This dataset contains information about laptops along with features that can help us to understand what factors can influence laptop's price. It includes details about the laptop specifications and the brand, which can be used to analyze and predict the price. Description of data. The data shows the relationship between factors that may influence laptop's price. In this case, we have selected processor type as the independent variable. This factor plays a significant role in determining the price of a laptop due to their influence on performance and user experience. By examining this variable, we aim to explore how the product specifications and brand can influence the probability of a laptop price. We have two variables of interest. The first one is independent variable is processor speed. The second one is dependent variable is price of the laptop. For the sample size, we have 1000 respondents. 2.2 is graphical technique. To understand how various laptop features can influence their price, we will use scatter plots and bar charts. Scatter plots are helpful for showing the relationship between continuous features like RAM, storage, and the processor speed. For example, we can see if the laptop with faster processor can tend to have higher price. On the other hand, bar charts will allow us to compare the average price of laptop from different brands or with different processor types. This visualization will help us to identify any patterns or trends. If the graph don't show clear patterns, it might suggest that these features don't have a significant impact on price.
On this slide, we are focusing on the numerical technique used to analyze our data. Specifically, we calculate the mean, which represents the average of the data values. The formula for the mean is shown here, where x bar is the mean, sigma x is the sum of all data values, and n is the total number of data points. This approach provide a central value that summarizes our data efficiently, making it easier to interpret and analyze. Next is the concept of the median, which is the middle value of dataset when arranged in ascending order. To calculate median, follow these steps. First, arrange the data in ascending order. Second, find the position of the median using the formula. Third, locate the median value in the ordered data. Here, x bar represents the median and n is the number of observations. The median is particularly useful for identifying the central tendency in a data set, especially when the data contains outliers. Next, we're going to shift to the mode, which is the most frequent value in a data set. It's important to note that the mode can have more than one value if multiple values occur with the same highest frequency. To determine the mode, follow these steps. First, arrange the data in ascending order. Second, identify the value of or values that appear the most frequently. The mode is especially useful in understanding patterns or trends in the data, as it highlights the value that occurs most often. In this section, we discuss the method of correlation, specifically using the Pearson's correlation coefficient. This method measures the relationship between two variables, showing the strength and direction of their correlation. The results can indicate if the variables are positively correlated, negatively correlated, or not correlated at all. Here's the formula for Pearson's correlation coefficient, which considers the covariance of variables divided by the product of their standard deviation. This helps quantify the degree of the relationship, whether it's strong, moderate, weak, or non-existent. The components of the formula for Pearson's correlation coefficient includes R represents the correlation coefficient itself. N is the number of observations. The summation symbol denotes various sums, the sum of the product of x and y value, the sum of the squares of x values and y values, the square of the sum of all x values and y values. Each of these terms helps calculate the relationship between the variables with precision. Next is the range and interpretation of correlation coefficient R, which ranges from -1 to +1. R equals to +1 indicates a perfect positive linear correlation between variables x and y. 0 less than R less than +1 represents a positive linear correlation but not perfect. -1 less than R less than 0 indicates a negative linear correlation between x and y. R equals to -1 shows a perfect negative linear correlation. Finally, if R equals to 0, there is no linear correlation between x and y, though other types of relationships may still exist. This slide shows how to determine the strength of correlation based on the value of R. R equals to 1 represents a perfect positive correlation. 0.75 less than R less than 1 indicates a strong positive correlation. 0.5 less than R less than 0.75 represents a moderately strong positive correlation. 0 less than R less than 0.5 suggests a weak positive correlation. R equals to 0 indicates no linear correlation.
Lastly, for chapter 2 is method of regression analysis. Regression analysis is a statistical method can be used to understand the relationship between two variables, which is a dependent variables and an independent variables. The relationship is shown with a straight line represented by the formula y equal to a plus bx, where a is the y-intercept, that the value of y when x equal to 0, and b is the slope, which is how much y can change for each unit increase in x, so that we can calculate a and b using the least squares method, which is can ensure the line fits the data as closely as possible. If b is positive, y will increase with x. If b is negative, y will decrease with x. This can help us to make a prediction and understand trends in data.
Next, I want to talk about chapter 3, which is result and discussion. 3.1, based on data obtained, we identified the dependent variable and the characteristic. We found that the dependent variable is the price and the independent variable is the processor speed. Both price and processor speed are classified as qualitative data. Next is 3.2, descriptive statistic analysis. For dependent and independent data gain, we will now make data analysis for the price of the laptop by the processor speed. These involve the measure of tendency, measure of dispersion, measure of position, skewness, and lastly range of the variable. The first variable that is dependent on its value is the price. The mean, which is indicated by the symbol x for this variable, is 2.7100729. This shows that the average price of laptop is 19,604.19. From the median x, we can interpret that half of the price is more than 19,604.9 and other half of it is less than that. As for the mode, we can conclude that the highest price is 800 1 for the standard for this variable is 9,406.096. For the variance S square is 88474056.52. The overall skewness of this variable that we obtain for table 3.2.1 is 0.366. This means that the distribution of the variable is skewed to the right or positively skewed as the value for the skewness is positive. This also shows that the mean value is to the right of the median. The range of the variable is 24933.192. This indicates the difference between the highest price, which is 33,503.94, and the lowest price, which is 8,570.10.
Correlation and regression analysis. The correlation value are from the table 3.3. We obtain that the value is 0.05074. This shows that the variables have a moderate positive linear relationship between the variables. On the other hand, for the coefficient determination R squared, the value that we obtain from the table 3.3 is 0.002574. This value determines the ratio of the explained variation to the total variations. This shows that only 0.3% of the total variation in the price and the remaining 99.7% is caused by the other factors. The scatter plot diagram in figure 3.3.1 below, we can interpret that it is a positive linear relationship between these two variables, which are the price and the processor speed. The diagram also shows that variable has very small positive correlation. The regression equation for the scatter diagram is y equal to 21397.99x minus 652.15. The value of A is equal to 21397.99 and the B value is equal to minus 652.15. The The value B indicates that when it's increasing in processor speed, the price will increase by 652.15.
In conclusion, laptop prices are heavily influenced by its specifications, which is processor speed. Based on data, we can see that the highest price is RM33,503 and 94 cent, and the lowest price is 8,570 and 1 cent. From the data, we observe that processor speed in laptops have 0.3% of the total variation in the price, while remaining 99.7% is affected by other factors. This demonstrates that improved specifications correlate with higher prices. Furthermore, the correlation and regression analysis indicate a strong positive linear relationship between laptop specifications and their prices. This highlights that if the processor speed increase, the price of laptop also increase. For recommendation, consumers prioritize laptops equipped with higher specifications, such as high processor speeds. These features contribute to enhanced performance and improved user experience. Next, consumers should also carefully evaluate RAM and storage types to ensure they align with their specific usage patterns and requirements, whether for work, gaming, or general productivity. Manufacturers can leverage these insights to optimize their pricing strategies and effectively target key market segments. This is crucial for developing more precise price prediction models, which enable a deeper understanding of emerging market trends and dynamics.